Hello everyone, and welcome back to the Fluctus Channel. Decommissioning a ship can occur for many reasons, such as cost-saving measures, obsolescence, or transitioning to new technology. The lifespan of a warship changes depending on its class, maintenance, and operational demands. From 45 years for a destroyer and cruiser to 30 years for an LCS. This decision to retire a warship also considers strategic priorities, fleet size, and budget constraints. This process takes over 2 years, depending on the size, type of vessel, and reasons behind its retirement. Usually, several steps are taken during the process of decommissioning, starting often with ceremonial events like flag-lowering ceremonies. During this time, it is common for all sensitive equipment to be stripped from the vessel before being officially removed from service. Then, after taking such equipment, sailors begin shutting down all the remaining systems, including propulsion engines and cooling systems. A disposal plan is then developed based on environmental laws, dictating whether parts can be recycled. This plan may involve options like scrapping, sinking as artificial reefs or target for weapons testing, preservation as museum ships, or transfer to allied or friendly nations for continued service. Often, these disposal processes include environmentally friendly efforts to mitigate potential hazards such as fuel, oil, asbestos, and other contaminants. With the disposal of old ships, maintenance costs will be reduced as fewer resources will be dedicated to maintaining these older ships. Also, this helps make way for newer and more advanced ships to replace them, thus modernizing the fleet. Disposal of a Navy vessel, including submarines, is a complex process involving several steps and the work of engineers and technicians. This is the case with the Ship-Submarine recycling program process by the United States Navy. They focus on disposing of decommissioned nuclear vessels at the Puget Sound Naval Shipyard in Washington. Such a program was established to handle the retired submarines in an environmentally friendly and cost-effective manner. Before the process can begin, the submarine must have its nuclear fuel removed, which usually coincides with decommissioning. Then, the vessel is surveyed to identify key structural features and components or other potential hazards. Based on this survey, the shipyard workers initiate to cut into 3 or 4 main sections. These sections include the aft section, reactor compartment, missile compartment, and forward section. To achieve this operation, the workers create a series of marks. This aids them in getting precise and controlled cuts to separate each section. Having this makes it possible to not inflict any damage to critical components or compromising structural integrity. Then, the operators can cut through the submarine steel using specialized equipment such as diamond wire saws, abrasive water jet cutters, plasma torches, or thermal cutting tools. After a decommissioned submarine is cut into the main sections, the hull parts are typically transported and moved within a dry dock at Puget Sound Naval Shipyard. Until 1991, the forward and aft sections of the submarines were rejoined and placed in floating storage. Since then, the remaining submarine sections have been recycled. Obtaining reusable materials for the production of new vessels, and to help reduce costs. The scrap metals and other materials obtained are sold to private companies or reused, which provides some cost relief. To get into this, specialized heavy lift cranes with high capacity and precision controls are used to lift and move the large hull sections within the dry dock. The movement of the parts is aided by a system of rails built at the dock. With this, the crane can maneuver the hull sections horizontally, transporting them from the cutting area to designated storage or processing areas within the dry dock. The operators must always be careful of any obstacle so they can navigate the cranes around the structure safely and ensure the precise placement of the hull sections. Being part of the RIMPAC event, the SYNC exercise, also known as SYNC-X, looks to enhance proficiency in tactics, targeting, and live firing against surface targets at sea. Those targets are former Navy vessels that are stripped of hazardous materials and environmental contaminants following strict regulations. Each exercise is required to sink the hulk in at least 6,000 feet of water and at least 50 nautical miles from land. To ensure that humans and marine mammals are not in an area, there are constant surveys to guarantee the animal's safety during the event. During exercises like SYNC-X, the participating navies may employ various weapon systems, including naval guns, missiles, and aircraft launch munitions to simulate real-world engagement scenarios. Just as with any weapon system, torpedoes require trained personnel to prevent damage and ensure proper alignment during loading onto launching platforms or torpedo tubes. To fire such weapons, the crew must follow some loading procedures and pre-firing checks, including power-up tests and sensor calibration. After firing, there are certain checkups to evaluate torpedo performance and validate the mission objectives. This shows the strategic importance of exercises like SYNC-X for training and validating the crew's capabilities in this scenario. Often referred to as the Boneyard, AMARG is a facility operated by the United States Air Force. It's located at Davis-Monthan Air Force Base in Tucson. It serves as an aerospace storage and maintenance facility, providing a service to all branches of the U.S. military. It was created in 1946 after World War II, and since then, it's been used to preserve, store, maintain, and regenerate out-of-service military aircraft. This will eventually result in a potential reactivation, cannibalization, or disposal of these aircraft as needed. The location of the AMARG was selected because of two main factors. Its dry climate helps to reduce the effects of corrosion on the arriving aircraft. It has a very hard subsoil, which is capable of supporting the weight of the largest aircraft. Over the years, the facility has expanded its operations, resulting in a growing inventory of surplus and retired military aircraft from various conflicts. While AMARG is primarily known for storing and maintaining retired military aircraft, it also operates a runway for final landings. This runway is vital for the Boneyard, as it serves as the designated landing area for the aircraft. This landing strip is the starting point for the newly arriving planes. When a new aircraft arrives, the facility personnel determine its storage status and send it either to the reclamation areas or the maintenance and long-term storage areas. Inside this location, a total of 3,200 aircraft, 6,100 aircraft engines, and nearly 300,000 line items of aircraft production test equipment are stored. Since the mid-40s, the facility has been storing B-29 Superfortresses and C-47 Skytrains. Over the years, aircraft such as the post-Korean War B-36 or the F-16 fighter jets have been kept here. AMARG uses official inventory type categories to classify the upcoming planes. A Type 1000 is designated for long-term storage, which must be maintained until recalled to active service. The opposite goes to Type 4000, which is assigned to aircraft that have been gutted and every usable part reclaimed. Such parts are meant to be sold, broken down into scrap, smelted into ingots, and recycled. Considering the first type, many of the stored aircraft can be returned to operational status in a short period, where the operators follow a continuous process of anti-corrosion and re-preservation work that keeps the aircraft in stable condition during their stay. When the aircraft is no longer operational, AMARG assesses its possible dismantling. The facility carries out a process of reclamation of spare parts and the eventual disposal of spent airframes. So by disassembling aircraft and recovering valuable materials and components for reuse or recycling, AMARG contributes to resource conservation. Properly managing the retirement of military vessels and aircraft is critical for environmental sustainability and resource conservation. Moreover, the proper decommissioning of aircraft preserves their historical heritage and enhances upcoming legacies by transferring resources to more modern and capable platforms. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.